Ladies and gentlemen of algebra, this is Unit 7, Notes 5, talking about independent and dependent events. But before we get into that, we'll do a little bit of review. So if you roll one fair number cube, better known as a dice, find the probability of each of the following. So a dice goes from 1 to 6. So the probability of 2, remember you want events that you're counting over everything that could happen. So that's just going to be 1 over 6. Probability of getting an even is going to be 2, 4, or 6. So it's going to be 3 over 6, better known as 1/2. Probability of a prime, that's going to be 1, 2, 3, 5. So that's going to be 4 over 6. So that's going to be 2/3. So a fair number cube is rolled twice. Find the probability of the following. So take a look at this. So if you're going to roll it twice, something has to happen and then something else has to happen. So if I roll 2 4s, that means I get the probability of a 4 and the probability of 4 again. So that's going to be 1/6 and 1/6. And anytime I see and, I'm going to multiply that. So a probability of a 2 and then the probability of a 3. So I get a 2 first. Then I get the probability of a 3. So now probability of 1 and then any number. Well, the probability of 1 is going to be 1/6. Then the probability of anything is going to be 6 out of 6. It doesn't matter what I get, it's going to be considered a success. So when I multiply that, that's going to be 6 out of 36 or 1/6. So that's what those are going to look like. So remember, probability, number of successful outcomes out of total number possible outcomes. So rolling a fair number cube, probability of rolling a 4, just kind of what I had on the other page. Independent and dependent looks like this. Independent means one has no effect on the other. So if rolling a die and drawing a card from a deck of cards, those two things are going to be independent events. Basically because one's not going to affect the other. So dependent events means one is going to affect each other. So some of the key words are going to be replacement or without replacement. Those are going to be kind of your key points. So if you see replacement, you think independent. If you see without replacement, that's going to be dependent. All right, and the way you do that is you're going to calculate what happens once the first event occurs. So independent or dependent. So choosing the size and color of a pair of shoes. So I'm going to call that independent because choosing the color has no effect on the size. Choosing the size has no effect on the color. Choosing the winner and the runner-up at a dog show. I'm going to call that one dependent because if you're the winner, you can't be the runner-up, and if you're the runner-up, you can't be the winner. Choosing a president, vice president, secretary, and treasurer for the student council. There you go. Boom. That's going to be dependent. Selecting a fiction book and nonfiction book of the library. One has no effect on the other, so that's going to be independent. All right, so the top and the bottom are going to be independent. The middle two are going to be dependent. So at a picnic, Julio reaches into an ice field cooler containing 8 soft drinks, 8 regular, 5 diet. He removes the can, then decides he's not really thirsty. He puts it back. What is the probability that Julio and the next person to reach in the cooler both randomly select a regular soft drink? Well, now, this is going to be independent, and here's why. He puts it back. Putting it back is like Julio was never there, okay? So he puts it back, and it's like you still have the same amount of soft drinks in the cooler. So what's the probability that both Julio and the next person grab a regular soft drink? Well, probably that Julio does it, it's going to be 8 out of 13. All right, 8 regular soft drinks, 13 cans of soda. That's going to be 8 out of 13. Then you got the probability of the next person. But remember, Julio puts it back. That means there's still 8 regular soft drinks in there, and there's still 13 soft drinks total. So that is going to be 8 out of 13 times 8 out of 13. So that's going to be 64 over 169. And that's about as simple as you can get that. You want to give me a decimal? It'd be about 0.38 or about 38%. All right, so that's what that would look like. So 3 cards are drawn from a standard deck of cards without replacement. Without replacement is my key word here. That tells me it's going to be dependent. Find the probability of drawing a heart, another heart, and a spade in that order. So probability of drawing a heart is this. So remember, there's 13 of each suit, so there's going to be 13 out of 52. But then you've got to draw another heart after that, so it's going to be 12 out of 51. Then you've got to draw a spade. Well, there's still 13 spades in there, and now there's only 50 cards. So the probability of doing that is going to be multiplying all those together. So when I do that simplified, it's going to be 13 out of 850. That's what my simplified answer is going to be. As a decimal, that'd be 0.0153. That's what that'd be. That's what that would be. So there are 3 mini chocolate bars and 5 peanut butter cups in a candy dish. Liz chooses 2 of them at random to eat. What is the probability that she chooses 2 miniature chocolate bars? So here's what I'm going to say. I'm going to call this one independent because once I choose the first one, that's going to change the way that it works. That's going to change the setup of the second one. All right, so what's the probability she chooses 2 mini chocolate bars? Well, for the first one, what's the probability that she chooses a mini chocolate bar? 3 out of 8. Then she's got to go in there and grab another little chocolate bar. Well, there's 2 left out of 7 total candies. So this is the first chocolate bar, and this is the second chocolate bar. So together, that's going to be 6 out of 56. So that's simplified is going to be 3 out of 28. I like it when you leave answers like this. That's a lot cleaner than giving me some big, long, ugly decimal. So I like it better like that. In a say lottery game, each of the 3 cages contains 10 numbered balls. The balls are labeled 1 of the digits 0 to 9. What's the probability that the first 2 balls will be even and the third will be prime? Well, that's going to be independent because none of the cages know what the other one's going to draw. All right. One does not affect the other. So it's a probability that you get even, and prime. Well, let's see. You got 2, 4, 6, 8. We're not counting 0 as even. Okay, so, well, maybe we'll count. So that'll be 1/2, and that'll be 1/2. Then we've got prime. So you got 1, 2, 3, 5, 6, 7, 8, 9. So that's going to be 5 out of 10 as well. So that's going to be 1/2. So what's the probability of doing that? 1/2 times 1/2 times 1/2. So that's going to be 1/8. So find the probability of drawing 3 cards of the same suit without replacement. So same suit without replacement, that tells me it's going to be dependent. Without replacement tells me dependent. 3 cards of the same suit. So for the first card, it doesn't matter which one I pick. Okay, first one is just going to be any card because you haven't determined which suit it's going to be. So that's going to be 52 out of 52. Then once I do that, say I draw a diamond, now I've got to draw 2 more diamonds. Well, there's 12 diamonds left out of 51 cards, and then there's 11 diamonds left out of 50 cards. So this is a great big giant 1. So that's going to be 22 out of 425. Simplified. Try to simplify your answers. It's a lot nicer when you do that. So a cage contains 3 white and 6 brown hamsters. Maggie randomly selects one, puts it back, and then randomly selects another. Ha! She puts it back. So it's like she never picked the first one. So that means it's going to be independent. So see, she takes 3 out of 9 hamsters for the first one for white. And then she puts it back and goes, hey, what's the probability I get a white one again? So that's going to be 3/9 times 3/9, which simplifies to 1/3 times 1/3. So the probability she goes 2 for 2 on the little white hamsters, is going to be 1/9. All right, don't go take the quiz on Schoology because it's not really there. Get any questions answered you need to, but be very, very picky. Look for wording. Look for putting things back or with or without replacement. That will tell you if it's independent or dependent, and then just multiply them together.